All right, folks. Good evening, everyone. One quick check with AV. Are we good here? Yes. Are we good to begin? One quick check with AV. Am I able to? Are you guys able to see me and hear me? Am I audible? Hello, hello. Are we good here? Just let me know the AV part. Hello, Athav. Hello. All clear. Great. So, without any further ado, we have started a bit late. We'll manage it. So, we'll be looking at the other part of progressions. We'll be talking about geometric progressions for the day. We already discussed the arithmetic progressions. In case if you have missed it, it is sitting here in the same playlist. Go visit that class, have one idea about arithmetic progression. We'll be doing geometric progression for the day. So, to begin with, what is geometric progression? Now, we know that when it is arithmetic progression, we say 2, 5, 8, 11, this is an AP, plus 3, plus 3, plus 3 and so on. This is an AP. What is a GP? Now, an AP can also be 20, 13, 6, minus 1. This is also an AP where the common difference is minus 7. So, you either add or subtract, that's an AP. You repetitive addition or subtraction will create an AP. What is a GP? A repetitive multiplication or division. Now, if I say 1, 3, 9 and then we say 27, 81, 243 and so on. Now, if you notice that into 3, into 3, into 3 constantly, or you can also divide, which will be 64, 32, 16, 8, 4 and so on. But the common difference is 1 by 2. Sorry, the common ratio. Here we call it common ratio. Here it is 1 by 2. You are dividing it. You are dividing it by 2, or I will say multiplying it by 1 by 2. So they both mean the same. Here we call it common difference, that is D. Here we call it common ratio, that is R. Clear? Simple idea, nothing tricky about it. Or the generic pattern of this would be A, and then you are multiplying R first time, AR square, AR cube. So the nth term, first term has 0 R's, second term has 1 R, third term has 2 R's. So nth term will have n minus 1 R's, or we say A into R power n minus 1. So a quick summing up, briefing it up. AR square, AR square up to AR power n minus 1, or we will say Tn is equal to AR power n minus 1 for any n value. That is how you find it, nth term. How do I prove that any given series is a GP? Now, when it comes to AP, second term minus first term, third term, the gap between them should be same, or the generic pattern would be T2 by T1, sorry, T2 minus T1 is equal to T3 minus T2. That's what we did. Here we say T2 by T1 is equal to T3 by T2, or from here we can say T2 square is equal to T1 into T3. From here we can say T2 is equal to the root of T1 into T3. called T1 into T3, or we call this as geometric mean. The geometric mean of any two numbers is given by the square root of the product of the two numbers will give you the geometric mean. Arithmetic mean will be the average of the two numbers. Geometric mean for any set of three numbers, if we call them to be in GP, the middle number will be the root of the product of the extremes. If I give you two numbers and if I ask you to find the geometric mean, you simply multiply them, take the square root, that will be the geometric mean. Clear? One important funda that we need to know. Any doubts? Any questions here? One quick question, one look at the chat here. All clear? Brilliant. Now if I move a little further and then look at what is the sum, right? We can find the nth term in this format. What is the sum of a GP? Now we all have seen sum of an AP. Sum of a GP is not that easy as what it was for AP. Now in AP we said sum of the first term plus last term by 2 is average, into n will give you sum. N into average of the extremes will give you sum. That's what we saw. But when it comes to GP, it's not that easy. There is a layer here based on two conditions. What is the nature of R? Oops. What is the nature of R? Now when it comes to R, it can be an increasing AP, increasing GP, or a decreasing GP. But how do I understand that? Now this is where we split our categorization into two parts. We say either R is greater than 1 or R is less than 1. Does it make a difference? It does. Now we have learned the sum of a GP in school. I know you have memorized the formula. If you have memorized the formula, nice. But sometimes it is utterly important that we understand why a formula exists. And in fact, the derivation of this formula itself is a theory part to solve a type of question. So I would recommend that you understand how the formula came into existence, because I think that is crucial to solve one set of questions, right? We can say, we will look at R greater than 1, first case, okay? I want Sn, sum of n terms of A plus AR plus AR square plus AR cube plus dot 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 up to AR power n minus, right? Now what I am going to do is, I am going to multiply this entire equation by R. This R, whatever value of R is, I want to multiply this entire equation by R. So what will you get? R into Sn is equal to A into R is AR plus AR square plus AR cube up to AR power n minus 1 into R would give you AR power n, right? Now I am going to subtract these two equations. Now tell me which equation is larger, 1 or 2? Hi Ashika, hi. What is which equation is larger, equation 2 or equation 1? Should you subtract 1 from 2 or 2 from 1? Will you subtract 1 from 2 or 2 from 1? Which one is larger? R is greater than 1, I have told you that. This is Sn, this is R into Sn. Should it be 1 minus 2 or 2 minus 1? That's important now. Which one will you do? Hi Sunil, hi, good evening. Now notice this, R is greater than 1. So if I multiply a number greater than 1, the multiplied number will be larger, right? If this is 2, R is 3, AR will become 6. This will become into 3, into 3. So this value, equation 2, is larger than equation 1. Can we say that? So I am going to subtract 2 minus 1. So minus, 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 everything will get minus. So on the left hand side, we'll have RSN minus Sn is equal to, I have AR here, I have minus AR here. These two will get cancelled. These two will get cancelled. These two will get cancelled. Everything will get cancelled. There will be an AR power n minus 1 here. That and this will get cancelled. What will you be left out with? Will be left out with this AR power n and this minus A. I want to take A common here. I want to take Sn common here. Sn into R minus 1 is equal to A into R power n minus 1. We need Sn, right? Sum of n terms of the GP. Sn is equal to A into R power n minus 1 divided by R minus 1. So sum of n terms of a GP is A into R power n minus 1 divided by R minus 1. But under this will be under the condition that R greater than 1. Clear? Any doubts? That is the next formula that we need to know. I want to write it here. A into Sn is equal to A into R power n minus 1 divided by R minus 1, considering the fact that R greater than 1. Now, what if R is less than 1? Think about the fact, if R was less than 1, can I say the second equation would be smaller than the first equation? We'll write it just in case. R is less than 1. Sn is equal to A plus AR plus AR square plus AR cube AR power n minus 1. R into Sn will give me AR plus AR square plus AR cube AR power n. Now I can say equation 1 greater than 2 because R is less than 1. So all of these values would be lesser than the original value, which means that 2 will be lesser than 1. So subtracting this equation from the first equation everywhere, this will become Sn minus R into Sn is equal to AR square, AR cube. There will be an AR power n minus 1 here, AR power n minus 1 here. So you'll have A minus AR power n. Once again, take Sn common. 1 minus R. Oops. 1 minus R is equal to A common 1 minus R power n, or Sn is equal to A into 1 minus R power n. Now this will be the sum of n terms when R is less than 1. Are we good here? Any doubts? Any questions here? You need to understand why this is happening, because you could straight away follow this part alone. But one type of progression question that has been asked in the past is called as an AGP, arithmetic geometric progression. Questions that follow a pattern of AGP needs to be solved in this format. So it's important that we know this as well, so that you don't have to learn it separately. You are learning a concept, you are learning why a formula exists. Parallelly, that idea will also help you in solving a type of question. So it's a win-win situation for us, right? So I'm going to write the next case as well here. Sn is equal to A into 1 minus R power n divided by 1 minus R when R is less than 1. But here comes one question. In this case, what is n is equal to infinity? What if n is equal to infinity? In the first case, when R is greater than 1, if I say n is infinity, R per infinity is a very large number. You cannot even find it. There's no way you can find it. But here, what happens if n is infinity? If I put R larger value, notice this. What is 1 by 2 power 1? 0.5. 1 by 2 the whole square will become 1 by 4, which is 0.25. 1 by 2 the whole cube is 1 by 8, 0.125. 1 by 2 the whole power 4 is 1 by 16, 0.0625. If you notice, when the power keeps increasing, the value keeps decreasing, right? So I know r is less than 1, it's a fraction, it is 0 point something. If I put n equal to infinity, keeps going larger the value of n, smaller the value of r power n. At some point, it will almost converge with 0, it will never become 0. Remember that r power n for any value of n infinity, it will never be equal to 0, but it is almost close to 0. In that case, can I say r power n will become 0? So what will be Sn? A by 1 minus r. Under what condition? If it is an infinite decreasing GP. When it is an infinitely decreasing GP, the formula would simply shift to A by 1 minus r. That's all. Nothing more, nothing less. Clear? Any doubts? So I'll write it down here as well. So I've written all the formulas consolidated. Sn is equal to A by 1 minus r when it is an infinitely decreasing GP. Any doubts? Any questions? So that's the utter fundamentals that you need to know about progressions, GP, to solve questions on GP. Now we'll try to plug in all these ideas in questions and then we'll see where it will take us. Okay. I want to show you a bunch of questions. So I want you to solve question number 1, 2, 3 and 4, 5 as well. Do all 5 of them. We'll solve all 5 of them. Alright. Have a go at it. I'll give you 5 minutes to solve all 5 questions because all of them are pretty basic, nothing complicated here. In 5 minutes, we'll solve all 5 of them. Go for it. What about question 6 and 7? We'll do question 6 and 7. These 5 of them are straight away application. These 2 will have to do some jugaad here. We'll do that. But these 5 you solve. These 2 I'll give you time and then again we'll solve it. Hello, Rajkumar. Hello. Good evening. I'm trying to decode your previous comment. सब वीडियो रिकॉर्डर चल रखी है क्या? This is live. Rajkumar, we are live. The session is happening live. I think I don't get your question right. Maybe you're trying to ask me something. I'm not sure what your question is. Never mind, never mind. Rajkumar, I don't think that should be a problem. In case if you're struggling to get this idea, you can again go back, start, watch from the beginning. You will understand it. But then if you're trying to get a proper idea about it, do watch the video that is on arithmetic progressions. We did a class on arithmetic progression last week, a live class we did that. Go visit that. See that video, that will give you one basic idea about AP, with which it is a lot easier to transition into GP. It's not that tough, provided you put in that effort. You will be able to catch up very easily. You don't have to be old or new, good or bad. If you can expose yourself to these ideas, it will get a lot easier. Right, we'll do all the 5 of them in one stretch. Some of them are not even a thing. The first term of a GP is 3, A is equal to 3, common ratio is 2, r is equal to 2. Find the sixth term. So T6 is being asked, ar power 5, ar power n minus 1. So that will be 3 into 2 to the power 5. 3 into 32, that will be 96. No prizes for guessing. Rajkumar, I think Swastik tried to tell you if you are trying to learn it in English. I think that's what he's trying to tell you. But then that's the assumption of the comment that I read. Just in case, Rajkumar, if you didn't know, every class on this channel will be all in English. We won't have vernacular language here. No regional languages will be. You will not get to hear any regional languages. This will all be in English. Just in case you didn't know. A lot of times people jump for the first time and they believe it goes in Hindi and English. The Hindi and English channel is the other one, the MBA wala main channel. This will be the English one. Just to give you a heads up. So this one is utter basic and simple. Nothing complicated about that. We'll move on to the second one. Find the sum of the first 5 terms of a GP whose first term is 2 and common ratio is 3. So first term is 2, A is equal to 2, R is equal to 3. Sum of 5 terms is asked. R is 3, which is greater than 1. So I will say A into R power n minus 1 by R minus 1. That I can write it as 2 into 3 power 5. Because 5 terms, sum of the first 5 terms. So n is equal to 5 by 1 divided by 3 minus 1. So this I can write it as 2 into 3 power 5 is 81 into 3, 243, minus 1 is 242, divided by 3 minus 1 is 2, 2 gets cancelled, so the answer is 242. Again, easy peasy, no sweating, it falls in place straight away, right? The second one's done. I think complicated up until now. It's simply plugging in the values to the formula and then we are taking it from there. In a GP, third term is 16, sixth term is 128, find the first term. So third term, T3 is 16, T6 is 128. From here I can say A R square is 16. From here I can say A R power 5 is equal to 128. I'm simply dividing both equations, equation 1 by equation 2. So A gets cancelled, R square gets cancelled here, we'll have 1 by R cube is equal to 16 cancels 128, 8 times 1 by 8. R cube is equal to 8, so R is equal to 2. You have the value of R, but the question is first term, which is A. I have to find the value of A. So I'm going to plug in this R equal to 2 in any of the equations and then find A. So I'm going to plug it in over here. A into 2 square is equal to 16. A is equal to 4. So the answer is, again, no issues dealing with the question. Plug in, learn what idea goes in and then you will fly. I repeat. Fourth one. The sum of the first 4 terms of a GP is 30 and the common ratio is 2. Find the first term. Sum of the first 4 terms of a GP, A plus AR plus AR square plus AR cube is equal to 30. And the common ratio is 2. So R is equal to 2. Let me take the A common. 1 plus 2 plus R square will be 4, R cube will be 8 is equal to 30. A into 1 plus 2 plus 4 is 7 plus 8 is 15 is equal to 30. A is equal to 2. So the first term is 2. That's all. Not 4, 2, Gaurav. You have corrected yourself. 2 is the right answer. Every time you get a question, we are solving some simple Very basic level questions to get the gist of how to progress. Now 6 and 7 will be on some challenge which we will do now. We'll do 5 before we go there. Look at this question. The sum of an infinite GP is 12 and the first term is 6. Find the common ratio. Sum of an infinite GP Sn is equal to 12. A is equal to 6. What is R? Now infinite GP is given. Now notice this. The sum of an infinite GP, can you tell me the sum of an infinite GP? Is it possible when R is greater than 1? If R is greater than 1, let's say R is equal to 2. For every term, the term becomes bigger and bigger and bigger and bigger. Can you even find the sum? It will be infinity. You can never find the sum. The moment it says sum of an infinite GP, we understand that R is less than 1. It cannot be any other case. R has to be less than 1. Only in that case this works. Now we can plug in. So Sn will become A by 1 minus R, which is equal to 12. So we'll say 6 by 1 minus R is equal to 12. From here I take it over there. 6 is equal to 12 into 1 minus R. So 12, this gets cancelled. 1 is equal to 2 minus 2R. This goes here and this comes here. 2R is equal to 1. R is equal to 1 by 2. Notice that we are getting R is equal to 1 by 2 and that is right. Clear? Question 4 is 4. Question 4 is 4. I am getting 2. Why are you saying it's 4? Athar also says 4. Oh, you are saying not 4. Bad. Okay. Sum of first 4 terms. So it will be A equal to 2 and then R2. 2 plus 4 plus 8 plus 16. Yes, correct. R is equal to 2. R cannot be 4. Clear? So we'll do the fifth one now. Fifth one's done. Now I'll give you some 2-3 minutes to solve question number 6. Have a go at it and then we'll talk. Now we have already seen a question of this type. In the last class of AP, we saw sum of 3 numbers in an AP and the product of 3 numbers in an AP. Do you remember how we took the 3 numbers in AP? When I say 3 numbers are in AP, we said A minus D, A plus D. We're going to do the same thing. Here I'm going to call the 3 numbers to be A by R, A, AR. So A by R into R is A into R is AR. So the common ratio is R through the time. Take this, we are through. So it's all about how I take those numbers. How do I take my variables and then we are through. So the first one says, if the sum is 26 and the product is 216. Sum is 26, product is 216. So let's do this. A by R plus A plus AR is equal to 26. We can take A common. So this will become 1 plus 1 by R plus 1 plus R is equal to 26. So this entire thing will become A into 1 plus R square by R is equal to 26. But then I think I'm doing a lot of things. I can cross multiply and then do it, but then I'm sticking with one equation and two variables, which is slightly inconvenient for us to solve. So what I'm going to do is I'm going to look at the other case. Product is given as 2 and 6. So what will I say? A by R into A into AR is equal to 2 and 6. That's all. In this case, R gets cancelled. A cube is equal to 2 and 6. Which cube is 2 and 6? A cube is equal to 6 cube. A is equal to 6. Now we have the value of A. We can substitute the value of A here and then solve for R. Let's happily do it. So I'm going to take this A over here as 6. So you will get 1 plus R square by R is equal to 26 by 6. I can cancel this off. This is 13 and 3. So let's write it in the next slide here. 1 plus R square by R is equal to 13 by 3. So cross multiply, you will get 3R square plus 3R plus 3 is equal to 13R. Bring it here. 3R square minus 10R plus 3 equals to 0. So I'm looking at two numbers. The product is 9, sum is minus 10. Do we have any two integers that satisfy? Product is 9, sum is minus 10, minus 9 minus 1 works. So this can be written as 3R square minus 9R minus R plus 3 equals to 0. I'm conventionally doing it. We know there is a better way to do this, but then for the sake of the calculation, I'm writing it the full form. I'm taking 3R common here, R minus 3. I'm taking minus 1 common here, R minus 3 equals to 0. So R minus 3 into 3R minus 1 is equal to 0. So we can say R is equal to either 3 or 1 by 3. It doesn't matter whether it is 3 or 1 by 3. If R is equal to 3, A is equal to 6, A by R, A, AR will become 6 by 3, 6 into 3, which will be 2, 6, 18. This is one case. The other case, R is equal to 1 by 3, A is equal to 6. You put this, you'll get the same three numbers. You'll get the same three numbers in the reverse order. It will be 18, 6, 2. Right? Sorry, 2, 6, 18. Yes. Clear? We are looking at 2, 6 and 18 or 18, 6 and 2. It doesn't matter because the question says find the largest number of the three numbers. Whether R is 3 or 1 by 3, the largest number is always, 18. 26 is the sum. And that will be our answer. Clear? Not that challenging, but then we just have to adapt to the idea to solve for it. Be clear? Any doubts? Atharv, right, absolutely correct. Now I'll do one last question and then we'll wind up for this GP idea. Nice question. It has one idea that we probably have to figure out and then solve it. Go for it. Gaurav is saying this one's a problem. GP is a bit complicated as compared to AP. Undoubtedly. GP is more trickier, more complicated, more time consuming than AP. But hey, GP happens to be the AP happens to be the youngest child. GP happens to be the middle child. You haven't met their eldest brother, right? You think GP is complicated? You're thinking about AP, who's the youngest of the lot. GP, who's the middle brother. There's an elder one who's called as HP, harmonic progression, which is painful, but then it's a nice idea. Again, to work with harmonic progression is good. You have not tested much on harmonic progression, but then there will be bits and pieces of harmonic progression when we do other classes. We'll talk about that then later. But harmonic progression is slightly more trickier than GP or AP. Help us out. Don't want to meet him, Gaurav, it's better, but meet him, don't be friends with him. You cannot say I don't want to meet him at all. You cannot say I don't want to know about this at all. You need to know, but then you'll say we'll stay apart. You will maintain the distance, the relationship, maintain it. Right, these classes are of Pioneer batch, or is this is a free batch, Saini Mishra. This batch, these classes are free. This is not happening on Pioneer. On the paid batch, the time, obviously there will be more time, and then we'll be talking about more set of questions that will be there. Here in this batch, the core concepts batch, we are covering all the basic concepts, and then maybe a couple of tough questions, some PYQs, a couple of PYQs. But of course, the paid batch will have more to offer. This batch, the one that we are sitting right now here, at this point, at this juncture, it is a free batch. Right, we'll solve this. The sum of an infinite GP is 15. The sum of the squares of its term is 45. Find the common ratio. Nothing fancy here. Sum of an infinite GP is 15. So I can say A by 1 minus R is equal to 15. From here I can say A is equal to 15 into 1 minus R. We'll keep this. Now, before I write this, there are two GPs that we are working with. The first GP is AR square, AR cube, and so on. So Sn of this will be A by 1 minus R, that is equal to 15. That's given. Sum of what? Squares of its terms. So the next GP will be square of each term, which will become A square R square, A square R power 4, A square R power 6, and so on. Now notice this, if you are squaring a term everywhere, this is still an infinitely decreasing GP, right? Still here R is less than 1 only. So what will be the sum of this GP? This you will say A square by 1 minus R square is equal to 45. That's all. That is all, right? A square is equal to 1 minus A square by 1 minus R square is equal to 45. Here we say A by 1 minus R is equal to 15. So from here I can say A is equal to 15 into 1 minus R. We can plug this A equal to 15 into 1 minus R over here. So what will you get? 15 square into 1 minus R the whole square divided by this 1 minus R square is equal to 45. So I want to expand this. 15 square is 225 into 1 minus R the whole square by 1 minus R into 1 plus R. A square minus B square is equal to A plus B into A minus B. That's all. This is equal to 45. So I can cancel 1 minus R and 1 minus R over here. 225 and 45 goes beautifully 5 times. 45 into 225, 45 into 5 is 225. So this will give you 5 into 1 minus R by 1 plus R is equal to 1. Right. So multiply this. 5 minus 5R is equal to 1 plus R. So this goes here and this comes over here. You will have 6R is equal to 4. R is equal to 2 by 3. The question is common ratio, which is 2 by 3, and that will be our answer. That's all. It's a matter of understanding. If this is an infinitely decreasing GP, squaring every term will also result in an infinitely decreasing GP only. Squaring doesn't change the pattern of the GP. Here A will be A, R will be R. Here A will be A square, R will be R square. That's all. Simple idea to work with. So that's all about that you need to know about GP. Learn them, practice these questions, try applying these funda to some moderate level questions, see whether you are able to take through that entire question. I tell people it doesn't matter whether you are able to solve a question. If you are taking time, if you look at the solution, if you are able to comprehend the solution itself is a great achievement. On your very first day, you look at the solution and then you feel like, hey, I didn't know this method existed, but I'm able to understand this method. If your thought process says, I can understand the solution, you are already in a great place. It is only a matter of time that you start incorporating those techniques. That's all. Right? Nth term is infinite cases always scares me. Gaurav, in fact, I like the idea of infinite. Nth term is infinity. I like that idea because there is a lot of questions that go well with that. Hang on. Just sit tight. You are just beginning. You have just put your first, you have just started the engine. You are not even throttling it. You are just starting the engine. So don't panic. Edith Sonas is asking, is this sure short question? Sure short question where? What do you mean by the sure short question? Define sure short. I don't understand the meaning of this question that you are asking me. What do you mean by sure? Is this a sure short question? All right, the rest of the people, do we have any doubts, any questions? It will come for sure. Things that you will never be certain of. This one of these things is this. Can I guarantee you one template question coming in the test? Of course not. No one can do that. But it's always nice to know a method. Anything that I teach in class, can I guarantee you this will definitely come? No. No one can. I'll go to the extent of saying, if someone says this question, this model question will definitely be there in the paper, they are lying. There is no assurance on how the paper will be set. We can guess estimate based on data, but even that is a guess estimate only, not proper data that we are dealing with. Okay. Yeah, I understood that. This is a direct question in the CAT exam. You can. I don't think I can guarantee you that. HP is not the younger brother. HP is slightly more tricky. The reciprocal of an AP is a HP. There's a lot happening over there. We'll talk about it some other day. Not today. Today, the idea is all about dealing with GP. Now that we have done that, we'll stop for the day. The remaining ideas and questions we'll discuss in the next class. In case if you haven't, once again, if you haven't joined the Telegram channels, I'll step aside for a second. Scan the QR code that will take you to the channel. Join it. Join the channels for more updates and proper information about everything and more content. Swastik, we will do one basic class on HP. We cannot brush it off completely. The idea of HP happens in time and work. Number of days is an AP, efficiency is HP. So we'll go there. We'll touch bases with HP. We'll just touch it and come back. We'll do that. Right. All right, folks. That's it for the day. Have a great week ahead. Have fun. Stay updated. Keep solving. Keep yourself fresh to learn anything new. And be aware of what you are learning. That's important. Right. We'll stop here. Thank you. We'll see you in the next class.